Hi everyone. In this video, we are going to solve a few more trigonometric equations. First, we are going to begin with this equation, sine of 5x plus sine of 3x equals 0. To solve this type of trigonometric equation, we have to somehow factor it, meaning we have to factor the expression on the left hand side. Now, how can we factor it? Well, we know a formula in trigonometry which says sine of c plus sine of d is equal to 2 times sine of c plus d over 2 times cosine of c minus d over 2. Let me make a quick note here. So if we assume that 5x is the angle C and 3x is the angle D, then we can easily factor the left hand side. So we can write it as 2 times sine of 5x plus 3x over 2, that is sine of C plus D over 2 times cosine of 5x minus 3x over 2, and all of that is equal to 0. And from here, if we divide both sides by a 2, then we are going to get sine of 5x plus 3x, that is 8x over 2, so that would be half of 8x, that is 4x. So sine of 4x times cosine of 5x minus 3x, that is 2x over 2, that will be cosine of x, just x, and that is equal to 0. Now we have a very nice factor form here. So from here we can say sine of 4x equals 0 or cosine of x equals 0, and we know that when sine of an angle is equal to 0, then that angle is equal to n times pi. So here we can say that 4x equals n times pi. N is an integer, of course. And from the other one, when cosine of an angle is equal to 0, we know that the angle is an odd multiple of pi over 2. So that can be written as 2n plus 1 times pi over 2. And from the first one, if we divide both sides by 4, we get x equals n times pi over 4. And from the second one, we have already gotten the solution where x equals 2n plus 1 times pi over 2. So these are the general solutions, and if we have to find the principal solution, then you can try various values of n, various integral values of n, like any integer value, right? Whether it's positive, negative or 0, you can try various integer values of n to find the different angles, and then as long as it is between 0 to 2 pi, 0 included, 2 pi excluded. So for principal solution, you can try various values of n, and that way you can find the angles which are between 0 to 2 pi. I hope it all made sense. Now let's take the second example. Our second example is sine of 5x equals sine of x. That's a trigonometric equation, and we have to solve for x. It is a straightforward equation here. It is like sine of x equals sine of alpha. This equation is looking pretty simple, and we already know the general solution for this type of equation when sine of an angle is equal to sine of another angle. So here let's assume that this is our x and this is our alpha. Then can we write the solution like this? But here we have a problem. We have x on both sides. So somehow we have to bring the x from the right hand side to the left hand side and then solve for x, right? So now let's take two different cases. Now what are those cases? Well, when n is an even number and n is an odd number. So those will be the two cases, right? So first case is when n is an even number. Let's take this case when n is even. Then what can we say? We can say, well, then 5 of x will be equal to some even number times pi. We can say 2k times pi. Now here we are again taking another integer k, and we are saying that some even multiple of pi, because we have considered n as even, so we can write it as 2k times pi plus negative 1 raised to the power an even number, that will give us a positive 1 times x, so that is simply positive x right there. And from here, if we simplify this, 5x minus x is equal to 2k pi, where k is an integer, and from here this is 4x is equal to 2k pi, and from here we get x equals k times pi over 2, where k is an integer, of course. And let's take the second case when n is an odd number. Now in this case, what can we say? We can say 5x is equal to some odd number, let's say 2k plus 1 times pi, some odd integral multiple of pi, plus negative 1 raised to the power an odd number, that will be negative 1 times x, so that would be negative x. So I should write negative x right here. And from here, if we simplify, if we bring the negative x to the left hand side, so that will give us 5 times x plus x, that is equal to 2k plus 1 times pi, and from here this is 6x is equal to 2k plus 1 times pi, and from here x is equal to 2k plus 1 times pi over 6. And those are the two general solutions here. This equation can also be solved in another way, so let's try that also. Sine of 5x equals sine of x. This can be written in this form: sine of 5x minus sine of x is equal to 0, and from here we can say, well, this is looking like sine c minus sine d. We know that sine c, sine of an angle c minus sine of another angle d, can be written as 2 times cosine of c plus d over 2 times sine of c minus d over 2. So from here we can write it as 2 times cosine of c plus d over 2. In this case it would be 5x plus x over 2 times sine of c minus d over 2, that is 5x minus x over 2, and all of that is equal to 0. And from here if we divide both sides by 2, then we are going to be left with cosine of 6x over 2, that would be 3x, times sine of 4x over 2, that would be 2x, is equal to 0. So we have two nice factors here. So from here we can say that cosine of 3x is equal to 0, or sine of 2x is equal to 0. And when cosine of an angle is equal to 0, we know the solution is an odd multiple of pi over 2. So from the first one we can say that this angle, which is 3x, this must be equal to an odd multiple of pi over 2. And from the second one, when sine of an angle is equal to 0, we know that the angle is equal to n times pi. So from here we can say 2 times x is equal to n times pi, and you can clearly see that from the first one we are going to get x equals 2n plus 1 times pi over 6, because we are dividing both sides by 3, and from the second one we are going to get x equals n times pi over 2, and those are the two general solutions in this second method. So essentially we got the same solution, just the look and feel is slightly different. In the first set of solutions I am using k as an integer, in the second set of solution I am using n as an integer, but they both gave us the same result, right? I hope everything made sense so far. Let's try another example. Cosine of 5x equals cosine of x, or it can also be given as cosine of 5x minus cosine of x equals 0, right? No matter what the form is, we can write it like this, and then when cosine of an angle is equal to cosine of another angle, we know that the general solution is the angle is equal to 2n pi plus the other angle. So from here we can directly write the general solution. We can say, well, the first angle, which is 5 times x, the 5x, is equal to 2n pi plus or minus the other angle. Now again we have to take two cases. In the first case we are going to take the positive sign, so we can say 5x is equal to 2n pi plus x, and from here if we bring the x from the right hand side to the left hand side, we are going to get 4x is equal to 2n pi, and from here we are going to get x equals n times pi over 2. If we divide both sides by 4, we are going to get x equals n times pi over 2, where n is an integer of course. And let's take the second case, and in the second case we are going to take the negative sign. So for this case we can say 5x equals 2n pi minus x, and from here if we bring the negative x to the left hand side, that becomes positive x, so it would be 6x is equal to 2n pi, and from here we can say x is equal to n times pi over 3. If we divide both sides by 6, then we get x on the left hand side, and on the right hand side we are going to get n times pi over 3. So those are the two general solutions for this trigonometric equation, which is cosine of 5x equals cosine of x. And of course n is an integer. Please assume that n is an integer, positive, negative, or even 0. Let's take another example. Here we have the trigonometric equation as sine of 5x equals cosine of 3x. It could have been given as sine of 5x minus cosine of 3x equals 0, or maybe cosine of 3x minus sine of 5x equals 0. No matter what the form is, we can write it like this, and from here let's write it as cosine of 3x equals sine of 5x, and this sine of 5x can be written as cosine of pi over 2 minus 5x, and here we have a nice looking equation, which is cosine of 3x is equal to cosine of pi over 2 minus 5x, and now in this equation we have cosine function on both sides. So using the formula of the general solution for this type of an equation, we can say that the angle on the left hand side will be equal to 2n pi plus or minus the angle on the right hand side. And again we have two cases here, positive and negative sign. So in the first case let's take the positive sign, and then we can say 3x equals 2n pi plus pi over 2 minus 5x, and if we solve this, we are going to get negative 5x coming to the left hand side will become positive 5x and another 3x, so that would be 8x equals 2n pi plus pi over 2, and from here we can say then x will be equal to, if we divide both sides by 8, then x will be equal to n times pi over 4 plus pi over 16, and that is one of the solutions. Let's also take the second case, and in this case we are going to take the negative sign, so we can say 3x equals 2n pi minus pi over 2 minus 5x, and if we remove the parenthesis it will look like 2n pi minus pi over 2 plus 5x, and from here we can say that 3x minus 5x is equal to 2n pi minus pi over 2, and that is nothing but negative 2 times x is equal to 2n pi minus pi over 2, and if we multiply both sides by a negative 1, then we are going to get 2x on the left hand side, it will become positive, and then on the right hand side if we rearrange, the negative term will become a positive term because we are multiplying by a negative 1 on both sides, and this will become negative 2n pi, and from here then x will be equal to pi over 4 minus n pi, and that is the second general solution for this trigonometric equation. I hope things are making sense so far, and we're going to take one last example here. Let's suppose we have a trigonometric equation like this, that 10 times sine of x minus cosine of x is equal to sine of x times sine of x minus cosine of x. Now if we bring everything to the left hand side, then how is it going to look like? It will be 10 times sine of x minus cosine of x minus sine of x times sine of x minus cosine of x. All of that will be equal to 0, and then from here if we take one common factor out, which is sine of x minus cosine of x, and then we are going to be left with 10 minus sine of x, all of that is equal to 0, and from here we have sine of x minus cosine of x is equal to 0, or from the other factor we have 10 minus sine of x equals 0, and from the first factor can we say that sine of x is equal to cosine of x. Now if we divide both sides by cosine of x, then we are going to get sine of x over cosine of x is equal to 1, and that is nothing but tangent of x is equal to 1, which is equal to tangent of pi over 4, and then from here we can directly use the formula for the general solution, that x will be equal to n pi plus pi over 4. So that is one of the solutions. Now let's look at the second factor. From the second factor here we can say, well then 10 equals sine of x, or if you read it the other way, sine of x equals 10, and that sounds kind of crazy because we know that the maximum value of sine ratio can be positive 1, no more than that, but here we have sine of x equals 10, so that is not a solution. So our only solution is right here, which is x equals n times pi plus pi over 4. That brings us to the end of this video. I hope everything made sense. Thank you for watching. See you in the next video.